Hello guys, good morning. My name is Muhammad Haikal Muazzam bin Muhammad Khairul.
And my name is Ahmad Akil Adi bin Hamdan.
My name is Ni Amirul Haikal bin Ni Muhammad Azhar.
My name is Muhammad Nazri Bashir.
We from Group 1. Today we gonna introduce you guys about 3 by 3 matrices. We gonna do question 1 from set A. So stay tuned guys for the video.
Hi guys, today I will discuss set A, question 1, A and B. So, for a question A, form the system of equation from the table above using variable A, box P, B, box Q, C, box R. So, for the first equation is 1A plus 1B plus 1C equals to 150. So for the second equation is 2A plus 1B plus 1C equals to 190. So for third equation is 1A plus 2B plus 1C equals to 200. For the question 1B, write the system in metric form. A equal to B. Basically, A is our coefficient matrix, which means it's made up all of the number in front of A, B, and C from each equation. Then, X represent our unknowns. That's A, B, and C. And lastly, B is the result of the total from the right hand side of each equation. So, it look like this. So, when we put it all together, it becomes AX equals to B.
Okay, now for question C. For question C1, write the equation in metric form. So, in the first column, 1, 2, 1. Second column, 1, 1, 2. And third column, 1, 1, 1. This is our A. And then for our X, we have A, B, and C. This is for X. And this is equals to 150, 190, and 200. Okay, next for question 2. Find the determinant. So, today we are using Sarus rule. And for Sarus rule, we firstly have to write our matrix A. After that, copy again our matrix A, and then we have to write the first 2 columns to the next of the matrix A, just like this. After that, make a cross line from left to right, just like this. After that, multiply it by line, just like this. After that, we have to minus it with the cross line from the right to the left also, just like this one. After that, write the answer of the first equation and the second equation. We have 6 minus 5 and our final answer is 1. So 1 is our determinant. Now we move to third question. So now you guys have to pay more attention. We want to find the minor matrix of A. So we have to write it like this. Minor A equals to M11, M21, and M31. For the next column, write M12, M22, and M32. Our final column is M13, M23, and M33. This helps us to find our final answer, that is minor matrix A. For example, our M11 is found by removing the first row and first column of matrix A, then finding the determinant of the remaining 2 times 2 submatrix. Then I calculate the determinant using the formula AD minus BC, just like this. Okay, now we have to repeat the same action for M12. Just take the 2 times 2 submatrix and using the formula AD minus BC to find the final answer. Now, we fast forward to the future where we have got our minor matrix A. Now, please remember to repeat our same step to every minor in matrix A. And we write our matrix with -1 and 1 and 3 for the first row, and then followed by the second and third row. Our final answer is minor matrix A equals to -1, 1, and 3, and then -1, 0, and 1. After that 0, -1, and -1. This is our final answer.
Alright, in this step we are apply the plus minor pattern into the minor matrix A. This pattern is known as the cofactor side pattern, and it follow this arrangement: plus minus plus in the first row, plus minus minor plus minus in the second row, and plus minus plus in the third row. We are apply this same pattern into each element of the minor matrix to form the cofactor matrix. So here we multiply each element in the minor matrix by its corresponding side. The side as the following cofactor matrix: begin plus minus 1 and -1 and plus 3. Second, negative minus 1 and plus 0 and -1. And the third is plus 0 and negative minus -1 and plus -1. So we simplify each element, so we get -1 and -1 and 3. Second, 1 and 0 and -1. And third, 0 and 1 and -1. And that our final cofactor matrix. Next, we move on the finding the adjoint matrix. We already know that the determinant of our matrix A is 1. So now we take the cofactor matrix that we found earlier and we transpose it. Meaning we switch the row into column. After transposing, we get the adjoint of A, which is like this. D is final adjoint matrix for our given matrix A.
For question 6, find the inverse matrix of matrix A. The formula used is A inverse equal 1 over determinant of A multiplied by the adjugate of A equal the adjugate of A. So our inverse matrix for first column is -1, -1, 3, and second column 1, 0, -1, and third column 0, 1, -1. Now let's move to question 7. Find the value of x. The formula used is x equal A inverse multiplied by matrix B. And now let's substitute the values into the formula. The value of A inverse for first column is -1, -1, 3, and the second column 1, 0, -1, and third column is 0, 1, -1. And the value of matrix B is 150, 190, and 200. And now let's multiply the inverse of A with matrix B. For the first column, we multiply it by 150. Then we add the second column multiplied by 190. And finally, we add the third column multiplied by 200. After calculate, the final answer we get is 40, 50, and 60. So the value of x is 40, 50, and 60.